there. I'll just go ahead. So the thing that I found really interesting was the idea of symmetry initially. Because if you wanted to just ignore everything we know about traditional harmony and melody, except the idea of a 12-note scale, right? So you have this system of 12 notes, what they call the Pythagorean system, where if you go up a fifth, a fifth, a fifth, a fifth, and you keep going like that, eventually it comes very close to an octave after 12 times. So that's a very fundamental approach to creating a scale. So we call that the diatonic scale. So as long as you accept the diatonic scale, then you would want to ask yourself, what is the most fundamental, the most perfect, or the most basic scale? So typically what you might look for, like in physics or in math, a lot of times people look for symmetry, right? So which of the modes? Yes. So some of these French composers who wanted to push the boundaries into other, so some of the French composers were looking at the whole tone scale, which is symmetric in terms of pitch. It's only 6 notes, and each one is spaced symmetrically, spaced uniformly. Some of them were looking at the octatonic scale, which goes half, whole, half, whole, half, whole, half, whole. These sort of symmetrical patterns. In terms of the diatonic scale, the most symmetrical is Dorian. And like Newton kind of looked at Dorian a little bit later, he said some of his ideas probably didn't hold water about it, but it's interesting to physicists, to people who are thinking in terms of just, without thinking in the whole history of major and minor modes. So then I became really interested in this other scale, the Mixolydian flat 6, which is not in the is not a diatonic mode. It's slightly different, but it's very beautiful, and it's also very symmetrical. So we can look at the different ways of analyzing these scales. We have what they call the 3 limit, where you analyze it with ratios that don't use any factors bigger than 3. So you can have 3 times 2, or you can have 3 times 3, but you can't have 3 times 5 or something like that, your prime numbers. Other numbers like 4 would be like 2 times 2, right? So anyway, and then 5 limit and 7 limit. And so I was looking at these scales and also at a couple other scales. So my determination was that the most fundamental scales are actually not Ionian or major scale and Aeolian or minor natural scale, but actually these 4, Aeolian, which is minor natural, Dorian, Mixolydian, and Mixolydian flat 6, based on the symmetries and some properties. So then what I did from there was to basically do the same thing that, well, okay, how to describe it best. There are 2 ways I could describe it here. You can raise the 7th, right? So if you raise the 7th of a natural minor scale, it becomes harmonic minor scale. So in terms of musical history, we're used to doing that. So anything where we raise the 7th, I just called it harmonic. It's not a great term, but it was just the easiest one to use. And then the complementary operation to raising the seventh is to lower the second. Because if you go down by a seventh, that's a second. And if you raise the seventh backward, that's like lowering the second. So I called those mystic. Not a great term, but it was just, it has a sort of mystic sound or something, so I just called it that. So that's one way to look at what I was doing here. But the other way to look at it is in terms of the harmonic structure. So if you see where you go, the vertical are major thirds, and the horizontal are perfect fifths. And so it winds up filling out all of these different forms. And then, like, Dorian has this sort of pattern, and all of the Dorians you look at will have this same sort of invariant structure, this unchanging structure embedded in it. And so it's basically taking these four harmonic structures and then kind of these variants of them. So basically what I came to the conclusion of was that these 12 scales could form a harmonic basis. And then within these 12 scales, you get the minor scale, the natural minor, you get the harmonic minor, you get the major scale. And the melodic minor is, you know, part natural minor and part harmonic. So then from there, this is another way that people sometimes do this graph, where they slant the vertical line. And so a triangle represents like a major triad, and a downward pointing triangle is like a minor triad. So you can see that these are very like symmetrical when you do this. You can see that this is just this flipped, and a couple of them even have the exact same shape. Like you can see that this one has the exact same shape. It's just when you consider a different note tonic. So so basically you could play in this harmonic structure, and if you just emphasized a different note as tonic, it would sound like a different scale. So anyway, I found that interesting. I kind of called that floating the tonic or secret passage or something. Then this is just a little program to kind of prove that these are all the possible combinations when you follow these three rules that are set out. So the rules being that you start with these three notes, and that you don't like crowd the notes together too much, and that any new notes get attached to these three. Anyway, sorry, I'm just talking on about this, but the bottom line is that these 12 scales were the fundamental basis. So then I was kind of looking at, I don't know if you've heard of negative melody or negative harmony.
Heard it. Yes.
Yeah, so I was looking at that online, and it was popular. So I was looking at, what if you took these 12 scales and you formed the negative? And then there's another way you could form the negative that's symmetrical. So like a popular way to form the negative scale is by going up a fifth and then coming down with the same steps. So if you have a scale that's like whole, half, blah, 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 then you'd go up the perfect fifth to the dominant, and you'd come down a whole, down a half, that way. And then what I call the second negative here is if you do the opposite. So like, let's say you have a scale that goes down a whole, down a whole, and then down a half. Then you'd form the negative by going down a fifth to the subdominant, and then go up a whole, up a whole, up a half. And anyway, when you do that process, it introduces a bunch of new scales. So some of the scales are like, well, the scales are like reversible. So like, let's say we take Aeolian and we find the negative is Ionian. If we take Ionian, which I call harmonic mixolydian, and take the negative is Aeolian. So these flip back and forth. So that's kind of cool that when you do this negative operation, the Aeolian goes to Ionian, the Ionian goes to Aeolian. And it introduced a bunch of cool scales I'd never heard of. But actually, when I researched them a little bit, they were very interesting. Ukrainian Dorian, Phrygian dominant, and anyway, some of them had different names. So when they had various names, I just put the different names on the same line. And then I was looking at how you can rank these scales in terms of brightness. So people talk about this in terms of the modes, right? So Aeolian mode is dark, and Ionian mode or major is bright, minor's dark, major's bright, we know that. And so people have sort of formed what they call a spectrum or an ordering of the different modes based on their brightness. And so I wanted to basically come up with a little formula that would give the brightness. So it's a little bit complicated maybe, but I kind of described it here under scale spectrum and tried to rank these different scales based on their brightness. So the brightest is Lydian here of all the scales that were formed, and the darkest is Locrian. And actually there's slightly more darkness than brightness, I think, but they split right in the middle.
Can I ask you a question?
Yes.
I wonder who can use this information about brightness of these mods? Is it who is it for? Is it for composers or for musicologists or
good question?
Practical.
Well, let's say that there were a game. Let's say that somehow there were a music generation system connected to this, right? Or something that could make music, maybe not good music, but something for like background music in a game, right? And so let's say that there were a metric in the game about how happy things were. Maybe like the sun is out and people are playing in the game and everything is nice. Then maybe there'd be a metric in the game for brightness, right? And the music generator would switch into Lydian mode, maybe. And then...
Yakov, I think this information can be suitable for newbie composers, for example, like me.
Who? Newbie composers? What?
Yes. Newbie composers like me.
No, it's a really difficult theory. Like it's not for newbie composers. It's like for musicologists.
Yes, I mean in practice. So it's Daniel make application. Yes, it's will be practice. So you can click and listen. I mean this, not to read.
It's interesting. Yes. I just want to say in the games there are primarily two types of mods. It's major and minor. That's it. Primarily.
Gypsy, Arabic, and Ukraine.
It's really rare things like.
It starts from setting, because if you need folk sound, yes, it's hard to use only minor and major. If you need folk sound.
Part of the reason that we like major and minor so much, I think, are just that we hear they're just the go-to. So much music uses them, and that we just get used to it. And I think that this theory, I'm hoping, can open up a lot of new sounds in 12-note music. A lot of people say that to get new sounds, you need to have a different scale with more notes, or you need to have different strange tunings. You can't just have a simple tuning. What I think is that actually the reason that 12 notes in our equal temperament has been so popular is because there's a lot we can do with it, and there's a lot left to do harmonically. That there's a whole realm to explore that does get, I mean, people use all of these scales in different music and in some popular music, but they don't have a system for using it. They don't have, there's no harmonic theory really. They just use it because they think, oh, look at that, I can change this note and it sounds interesting. They're not thinking, oh, there's no instrument, there's no map, there's no functional structure, navigator or something. I don't know.
Yes. I want to add something. It's I think it will be really interesting and useful for contemporary composers who work in like experimental genres, because they really care about theory and about like how can I say, about how music was made, like in digits, like 12 atonal system, you know what I mean. Atonal system, 20 tones, etc. So I think this application, it will be really interesting for those kind of people. Maybe I'm wrong, I don't know.
It may be. My hope was to make it popularized among, like to make something where typical composers and people who are really close to music and instruments could somehow use it. But actually, maybe it's a good idea to start with people who could explore ways. I was trying to learn about modulation because I was thinking of that as the main mechanism here. So instead of thinking so much in traditional functional harmony, like going 1, 6, 4, 5, 1, blah, or whatever, I was thinking more about maybe a simple harmonic form, but more about how to then modulate between all of these different scales. So the way that I was thinking to try to do that, to define how to modulate from one scale to another, was through this idea of seventh chords. There's this interesting book, this guy Richard Cohn, and some of the modern, more contemporary music theorists have been developing these theories based on a harmonic structure and a voice leading structure. So basically, like if you take a chord, they basically try to say this chord has a certain distance from another chord, and that distance is based on how many half steps you have to take in order to get to the other chord. But there are other ways to measure that distance. Sometimes they might say how many common notes does each chord have? So if one chord is C, E, G, and one chord is C, E, A, they both have a C and they both have an E, so that's one way of measuring the distance. Another way is harmonically. It turns out that the harmonic way of measuring is very similar, but not quite exactly the same as the half-step way of measuring. To say, okay, it takes 2 half steps to get from this scale, this chord, to this other chord. Anyway, so they created this map. And then this is for triads. This is for tetrads, for 4-note chords. This one's for 3-note chords. But if you consider 4-note chords to be extensions of 3-note chords, you could also consider this one to be a sort of map, and they connect together in that case, so it's all like one map for 4-note chords. And then I was trying to extend that to the notion of scales. So each 4-note chord, each tetrad has an associated scale, and so this would give a map of how to move from one scale to another scale. And then this is in each scale what the tetrads are, what the different. So basically I was thinking to try to put this all into a program and have it give possibilities for modulations for moving through the map of scales. And I think it would wind up making some really cool sounds, some new harmonies, and something that you can control the level of brightness, or you can control with some sort of input, like a composer could put in a theme or some snippet of music. Maybe it could start modulating it, or it could somehow work with a composer. That would be the hard part, I think, to know how to integrate it with traditional composition software.
Can I ask you a question?
Yes.
Are you want to finish this application like yourself, like alone, and or like invite some people, like other programists, and?
Yeah, that could be a way to do it.
And later you are you want to find some publishers, yes, for like publish this application, or what's your plan about that? It's really interesting.
Oh, thank you. I think my thinking was to try to write a that could, say, output a series, a sequence of, basically it would be a scale, and it would be a scale degree. So it might say something like Dorian, 5, 7, and then Aeolian 1, something like this. It would basically give you the scale that you're working in and the scale degree of the chord. I'm thinking 4-note chords, and in 12-note scales, but some of this, 7-note scales, because it's a subset of the 12. But some of them might also use 6-note whole tone scale, some might use 8-note octatonic scale. Anyway, but basically I'm just thinking to try to output text. Then, given a file that has these scales and chords, then to try to read that into either music generation software or a sound synthesizer or something, and